In this video, we'll show you some demonstrations of interesting physical phenomena. First, we'll show you a magnet falling in slow motion inside an aluminum pipe. Here we have a clear acrylic tube that does not affect the magnet's motion for comparison. As you can see, the magnet takes significantly longer to fall through the aluminum section. This is due to Lenz's law, which states that as a magnet moves relative to a diamagnetic material, eddy currents are induced. These eddy currents create their own magnetic field, which resists the motion of the magnet.
Next, we'll show you a simple Gauss gun. Similarly to the popular Newton's Cradle desk toy, this device transfers momentum from a steel ball at one end of a system to a steel ball at the other end. One difference here is that we've added square magnets. Note that even though we push the ball very slowly, the ball at the other end is fired off rapidly. Although it looks like the system violates conservation of momentum, when we slow it down, you can see that the first ball is actually accelerating as it is pulled in by the magnets.
Here's an example of magnetic levitation. Inside the base of this device are a permanent ring magnet, 4 Hall effect sensors that detect the position of the levitating magnet, and 4 electromagnets controlled by the Hall effect sensors that push the magnet back to the center. This is necessary because no static arrangement of magnets can produce a static potential well in free space. This device can support up to 350 grams of weight and can even be oriented vertically such that the magnet floats next to the base without anything directly underneath it.
Finally, we'll show you a home-built setup to transmit audio over a laser beam. On the left side of the setup, we have a laser that is powered by a function generator. Here, we're just using it as a 2.7 volt DC supply. The breadboard contains a resistor and a capacitor that are used to mix the DC offset with an audio signal, here playing MP3s from my cell phone. Note that the capacitor also protects the phone from the current generated by the power supply. The right side of the setup consists of a phototransistor detector circuit that feeds a high-pass filter to remove the DC component caused by the laser always being on. The resultant signal is sent directly to the speakers. Note that there is no wire connection whatsoever between the two sides, and the music is being carried by the laser beam. As you're about to see, blocking the beam stops the audio entirely.
Always in time. Up this blood stays divine. See, up this. So, Stephen Show, really.